Hello there, I'm David Sanchez-Hernandez, CEO of EMITE, and we're here to show again an exciting measurements for over-the-air testing. In this case, a worldwide unique thing, which is to measure 3 downlink carrier components over the air with the following equipment. We have a brand new box from EMITE, the MT8821C. It's just been released. Has never been shown to test 3 downlink carrier components over the air until today. We also have an EMITE E500 reverberation chamber, and we're gonna see how easy those measurements can be using the EMITE software that we have on the screen here. It's very simple. We set the active MIMO OTA mode for measuring LTE advance. We select a predefined setup for the measurements. We're going to measure LTE, FDD, band 1, band 3, and band 5. Open the file, and we can check before running the measurements what's the setup that we're going to run. We have here on the screen that we are using an E500 reverberation chamber plus the EMITE MT8821C E-Node B. If we click on the measurement that we're going to run, it's a throughput measurement. We can see here that there are one primary component, one secondary component, and a second secondary component for the EMITE E-Node B. And the power control shows that we can set the physical channel parameters here as well as the power level for both uplink and downlink. The connection setup shows that the primary and secondary 1 and second are in open loop spatial multiplexers, so this is a MIMO test. And the downlink MCS is 20, so that's 64 QAM for all the carrier components. We're going to run a throughput curve in regular averaging mode, and we'll go from minus 85 dBs per 15 kilohertz to all the way down to minus 120, and that's RS EPRE. We can define here as well the sensitivity. If we're searching for a value for sensitivity called MTS or MIMO throughput sensitivity, and in this case it would be around 74 megabits per second. That's roughly about 70% of the maximum throughput. The number of frames, the calibration that has been loaded for band 1 in the primary, band 3 in the first secondary, and band 5 for the last secondary, as well as the accuracy we're going to run in a stepwise manner. So we're going to see a set of curves that will be measured and then averaged to get the final value. So it's very easy. We just click on next to run the measurement. First thing that we will see is on the screen of the EMITE MT8821C, we will see how our software sets the network to be tested. So basically all the parameters that we've been deciding on the software will be downloaded to the E-Node B. Then the connections that you need to establish the RF connections will be propped up by the software. You need to check that everything is in place. We have here a complex RF structure for these 3 downlink carrier components plus MIMO going into the chamber, and then it comes the attachment time. We're also going to see here that attachment of the device under test is quite easy. We'll have one of the latest brand new devices in the market for carrier aggregation with 3 downlink carrier components. It's very simple. We open the door of the chamber. And we simply put the device inside like that, and we can see on the screen of the EMITE how the connection is made. The chamber, as you can see here, it's empty. You have the absorbers for the delay spread, RF connectors at the back for the passive measurements. You have the steerers that you can see on either side, and in fact everything becomes very simple in this system. So we close the door and see that we can confirm that the device is connected. to the test network. If you're going to remote with the touchscreen, this is the MT8821C with the touchscreen, very useful. You can see the primary component, that's a summary here on top showing the channel and the band and the bandwidth, but we can also scroll down the RMC components in downlink or uplink. And we could do the same for the secondary component number 1, which is band 3, and check the parameters, and also for the one in secondary component number 2, and that's band 5. For the measurement pane here, we can see how the measurement will progress. All we have to do here is to run the measurement, and that will start. We will see here how the throughput is being measured, and basically we're expecting well over 100 megabits per second, so we can monitor that either in this text mode or in display mode here. And this is it. We are looking at 3 different curves evolving. That's basically the primary, the first secondary, and the second secondary curve here, and an overall that gives you the entire throughput provided by the device. Now, the way the throughput is being measured in the reverberation chamber is that you have a sample that is being measured continuously, and once you get sufficient number of samples, those are averaged to get the final curve. So this is why you see on the screen a number of curves evolving, and then as we collect samples, those are averaged out into the final value. So you will see here 4 curves. You're starting to see how these 4 curves are evolving. This one here, in gray color, seems to behave the worst ones out of all 3 components. That is actually the secondary component. That's the secondary component. That's then the blue, dark blue is the secondary 1 component, and the light blue is the primary. And you can see here how the overall curve, which is also being measured, is the composition of all those 3 downlink carrier components, in a way that it basically falls when one of the components falls. You can see that on the overall. When the secondary falls, you can see that as well, and then finally it falls following the primary, which is the one that behaves better than any of the others. And so therefore you have, for the first time worldwide, you can see real-time 3 downlink current components measurements over the air with the reverberation chamber. So this is going to take some time until measurement is finished, and you can also see that on the screen on the Enritsu, that you can monitor that. And basically this is it. It's trying to make MIMO measurements simple with the reverberation plus eNode B system. While the measurement is being taken, we can have a look at the software that gives you the chance to monitor the measurement in text mode, so that you can see the percentage that it's progressing on the measurement. Also, you can see a summary of your measurement, and this is useful when you have a large batch of measurements. This is prepared for automated handover and call drop processing, so that we're only running 1 throughput measurement today, but you can run a number of measurements, including different technologies and bands and figures of merit, so that the software will automatically hand over everything. And there is another video that you can see for that. And basically here you get a summary of your results as these are being measured. You can also see the properties of the measurement that you have set. Basically that we're measuring carrier aggregation in three bands, band 1. Here we have band 3, SCC1, and band 5 SCC2. And open loop. You can also see the settings for the throughput, number of set frames, if you have set an MTS value to be searched, and then obviously the range of power that you're actually measuring for the throughput curve. This doesn't have to be necessarily the same for all the carriers. You can actually set a power value for the primary that is different for that of the secondary, and vice versa, in case you want to do that. And then when this is finished, we will see, go back to the display, we will see that everything is finalized and saved and automated in a report that is easily to handle and deliver to your customers. Okay, so this is how measurement progress for the OTA system. We're roughly finishing right now. This is the last sample. So we're going to see that it is also quite fast. And this is it. You see here, yep, measurements are finished. You can see here in the software that you end up with 4 final curves: the performance of the SCC2, performance of the SCC1, and performance of the primary, and the overall performance in terms of throughput, well over 100 megabits per second. Then you can save the file. You can specify also a name for your device and a model, or even get a glimpse of the summary of the results for your device, about 5 minutes. We save that. Let's save it as test 2, and then we can simply open up the report in protected HTML mode. That's the format here. Again, we can see that we have an Enritsu MT8821C connected to our system. The base and specific signaling firmware versions are captured from the instrument and displayed here. You have the summary of your measurement, and then you have here a summary of the details. You have basically for all the power values that you have measured. You have the PCC throughput, the SCC1 and SCC2, and obviously the overall, giving a maximum of 106 megabits per second. And then all the summary of the settings, as well as the final curve of your results. So this is it. Yet once again, very simple MIMO OTA measurements for a brand new box from Enritsu MT8821C in combination to EMITE E500 for LTE Advanced carrier aggregation with 3 downlink carrier components. Thank you very much.